Here's a horizontal output tube and here's the damper. And I actually already have replaced all the critical components back when I restored this. So here's that 82 ohm resistor that I was suspicious of, but it's already been replaced with a quality metal oxide, flame-proof type. And likewise, all the caps have been replaced. So my first thing I want to check is, well, I'll check the bias voltages on this horizontal output tube. Here's a horizontal drive control. So the signal comes out of the horizontal oscillator through this mica cap to this guy. And this wire here goes to the grid, I believe, of this tube or something to that effect. Yeah. Check that on the schematic. And there we go. That trimmer cap, that's a drive control. So signal comes from this circuitry here, the oscillator, through that 390 picofarad cap, that 330 ohm resistor to the grid of horizontal output tube. That drive cap there is to form a capacitive divider which can adjust the drive level to this output tube. And adjusting that does have some effect, so I think it's working okay. As I say, I've replaced all these components that are in frame right now, except for the 390 picofarad mica cap, which is this guy, which I did not check. I did check some of these micas while troubleshooting the horizontal hold stuff, and I checked all these resistors, but that is my next best guess as to what the problem is. Okay, I finished my voltage checks in the horizontal output tube and the horizontal oscillator in AFC. This was about minus 27 volts, that about 150, and that about minus 15. And then the horizontal output tube, this is about minus 7.5. So that's a bit low, and that's the grid, meaning the tube isn't conducting as much as it should be, and these are really out of whack. So that's pins 4, 5, and 6 on the 6SN7, which is the AFC control tube of this guy. Now, I've already checked those resistors. I can check them again. And really aren't any mica caps directly on that tube. The ones preceding it, these I did check while debugging the sync issues. But I don't believe I've checked that one. And as I mentioned earlier, there's that guy. And then there's also this .002, which I think is this guy. And that puzzled me when I first started working on this set, because I think they show that as being a paper cap in the service info. I'll double check on that. But there's a mic on there, and I don't think it's the original. I did test it way back when, but may have failed since. Definitely want to check that guy, and one mic down in there, and one buried down in there. Well, unfortunately, the two mica caps that were my prime suspects both test okay. Both. Some thunderstorm going on up there. They test great both in capacitance and zero leakage, so the hunt continues. Okay, I just unsoldered the ends of a couple more mica caps, including this big guy that I was a little suspicious of. So, first off, I want to check the capacitance. It's kind of right at the edge of that range. Let's try it over here. Yeah, 2000 picofarad, just like it's supposed to be. And no leakage. Alright, try the other one. I'm running out of stuff to test at this point, which is rather frustrating. No voltage. Eye's not real distinctive like another mica cap that I replaced down in here. It's opening, but it's not super sharp. And let's see, it's a pretty low value. 250 picofarad. When you get down to that bottom end of the range, the accuracy kind of falls off. I think it shows 120 on the schematic. It's a little hard to read that guy. Or maybe it's supposed to be 300. Let's see. 1, 2, 3, 4. I think that's this guy. It's supposed to be 120. Doesn't look like that from the pattern of dots on it, though. Well, I'll keep poking away. There's only one more mica down in here to test. And I tested all of them in this area. All the resistors test good. I suppose there's a remote possibility one of the plastic caps I used has failed. Or maybe there's a dirty pin in the socket, but I've swapped out that tube a few times, and each tube has behaved the same way. I just fired up an AM radio to listen to. Kind of impossible with this intense a thunderstorm going on. I think I might be onto something. I was trying to figure out what mica cap this is supposed to be. The schematic shows a couple 120 picofarads going to this end of the cap. Now there's a green wire running down here. And there's 220 picofarad mica caps down here, which I tested earlier when I was checking the sync tube. So what's this third one? Well, I'll look closer at the schematic. So there's the .002, and there's the two 120s, and there's a wire going down and around and around and around. And there it is. So it's supposed to be only 4 picofarad, or 4 microfarad. And it goes to a 560K. Now this thing really isn't capable of measuring as low as 4 picofarad, but on the lowest range I'm actually measuring about 250 picofarad, so that might be problematic. But I think what might be a bigger issue is the other end of it is going to this tie point and this resistor. That schematic called for a 560K. I put a 560 ohm resistor in there. So that may very well have fried open. I gotta check that. I also want to double check the schematic. I want to find a different source. This is from Riders. I'll check the Sams or the Beatmans. And I got a Wallace Telly-8 around here somewhere too, because I'm not saying I didn't make a mistake, but that's a pretty drastic mistake of being off by an order of 3 magnitudes. It's 1,000th of what it should be. So that could definitely cause some problems. Alright, that was definitely supposed to be 560K. Not only did all the server's info say so, but I looked at the original reference photos I took before I restored this set, and I could see this resistor clear as day, and it was a 560K, so my bad. Now, as far as this capacitor, it is supposed to be 4 picofarad, rated for 1600 volts. But I also found out that this capacitance meter does not work well when you get down to below 200 or 300 picofarads. Just the leads alone, or with the leads spread far apart, or even pulled out of the meter, you start getting deflection down in this range. So, for example, I pulled out a 20 picofarad cap, and it measured about the same as this cap. So I'm just going to assume that it's all right, and that resistor was wrong. Now, how this set could have been playing better before with that wrong resistor in there, I don't know. But let's see if it made any difference right now. Doesn't look like it. Grr. So the search will continue. Same problem, dim, out of focus. Alright, well, there's the grid of the 6BG6, and that is 50 volts peak to peak. And it's a little bit jagged towards the start, just like they show. Alright. I'm not sure where exactly that junction of those two components is, so I'll have to check on that. But before I do that, I could check the damper. It's a cathode, pin 8 of the 5v4. It's this guy up here. Notice they have the heavy insulated wires on it, so I'm not too crazy about poking around in there, but I'll try to be careful. Let's see, pin 8. It wraps around, and it's actually this point right up here. Alright. 72 volts peak to peak. Whoa. Should only be 25. And the waveform looks totally different. Now I have swapped out that tube, but that sure doesn't look right. Now, you know, there is always a possibility that the flyback has gone south, which would not be cool, because it could be a little tricky to replace. Okay, here's the junction of R60 and C54. Should be 40 volts peak and have that weird double hump. What I've got is 100 volts peak and no weird double hump pattern, so something is very much amiss in this area. But we know that this is good, so we can forget about all this stuff being bad. It's got to be something right in here. And you know, I suppose one possibility might be that this 500 picofarad high voltage filter cap has gone leaky. Yet to see it really happen before. I've suspected it in a few other sets and replaced it with no, like in that RCA 630TS, I thought that it might be bad and I replaced it and it made zero difference. But it's kind of easy to get to, and I do have some spares, so that's one of the simpler things to test. And I can check the DC resistance on the flyback. I noticed the blue light flashing on my phone, which means you've got a pending notification, and this is what I saw when I turned it on. Not surprising with all this rain we've been having. I removed the high voltage cage and I've been examining the flyback and associated components, and I'm just about convinced that this is a replacement flyback because I'm seeing a lot of differences between this and what's on the schematic. First up, there's flat out 3 resistors that are not present. The 33 ohm going to the cap on the 6 BG6 is just gone. This is a straight wire going right to the flyback. And both resistors that go across these coils here, the 4.7K and the 3.3K, are not present. Here's those 2 coils, and there are no resistors in here. They're just wired in straight. And finally, these mica caps, there's 2 of them connected in series. They're not on here. I've seen similar things in other sets, and typically I think they added these to try to increase the width. Also, the resistance readings I've gotten differ a bit from what's on here, so that leaves me kind of scratching my head. First thing I'm inclined to do is remove these 2 caps. And it occurred to me too when I opened this up that there might be some arcing or shorting in here. This wire looked a little bit blackened, although, you know, I'd had this running for a while and no arcing, no ozone or anything, but well, maybe it was just being a bit obscured because of that cover. I don't know. Oh, and it is possible that those resistors I mentioned are like inside these coil forms down at the bottom or something like that, but I've never seen that before, and they do label them as specific components on the schematic, like R65, so I would think it would be somewhere visible up here or right underneath down here, and I cannot find either one of them. So what I'm going to do next is remove these two mica caps, reinstall the tubes, fire this up, and observe this area in darkness and, you know, see if there's any arcing or anything. Try to keep these wires out of the way. I'm not sure why they used a wire this long. It seems overkill. It's just going from here to here. So I think with this, the damper tube goes in right here, and this was mushed up against it. That tube gets pretty toasty, which is why I think these wires are blackened here. Yeah, I think it's safe to say that that capacitor was in there to increase the width. With it out, you can see how much skinnier the picture is now. And I don't detect any issue with any arcing or ozone or anything. No corona. Nice blue glow on the horizontal output tube though, but that's not because it's being overdriven or anything. Some high power tube is just glow blue on the inside of the glass from stray electrons sitting there. No big deal. Alright, so now what do I do about this? One, I'll ask around, or I'm going to review the thread when I originally restored this set. I did a restoration diary on Video Karma, and I kind of recall somebody saying that this wasn't an original flyback. And I'll see what I can do about it. I'm pretty sure it was working. I'll watch the video again and check out what the performance was like earlier. Because if it was working then, I should be able to make this work now. It's just tricky to say what I should do, because if this isn't an exact replacement, then I may need to deviate from the schematic to make it work right. I checked out width and linearity coil, and they seem to be okay. Also replaced the high voltage capacitor, made no difference. But what I have noticed is now that I'm down at this angle and I can look up inside that rectifier tube, the filament glow is like non-existent. The set's on right now. It's been on for a while. I've seen these tubes before when they're fired up. You can see that filament glow. And this one is incredibly dim. Now the filament for the supply for this tube is derived from a winding of wire around the ferrite core of the flyback. So there's not really much that can go wrong with a piece of wire, but I can check to see if it's open. You never know. Or maybe the tube pins are really dirty or something. But that seems like a bit of a... I just had a thought. I was about to put back my little stash of high voltage filter caps when I noticed I've got some solid state high voltage rectifier diodes. I could use a couple of these. I say couple because they're rated for, I think, 6.5 kilovolts. So not quite enough. I have to put a couple of these in series. And I could use these, assuming they're good, in lieu of that 1B3. So if the issue really is weak filament juice for whatever reason, you know, pop the tube out and stick this guy in there. Just a thought. Okay, here we go. Remember, kids, don't try this at home. Now, what do I suspect is going to happen? I think it's actually going to be somewhat similar to the 1B3. Well, either it's going to do nothing because these diodes aren't good, or I've got it in backwards, or it's going to be about the same as with the 1B3, which has a very high internal resistance, but these have a fairly high internal resistance too. After all, they were made for the same purpose, high voltage rectifier and TVs. So here goes. Nothing on the screen yet. Yep, same deal. Very faint, very slowly coming in. So it's behaving exactly the same. Actually, if anything, it's even a little worse than with the rectifier tube. I'm not completely giving up on this flyback just yet. I figured it couldn't hurt to pull out a flyback tester and poke around with it a little bit more. So first I did what they call the quick test, which is just to pop off the horizontal output tube cap and hook up the red lead to that and clip the black lead to chassis or ground, and then hit each of the 6 buttons and see if you can get the ringing test up into the good. I couldn't. The best I could get was about 6. So they then suggest we'll then start removing loads from the flyback. So first I'm going to just take out the 1B3 because having that installed completes the circuit for the filament loop, which puts a load in the flyback. Well, taking that out didn't make any difference. So next I just disconnected the yoke by disconnecting this cap, and now I can get into the good, well into the good. So it makes me think this flyback is actually good. Now that's not a thorough test. That's still kind of what they call a quick test. To do a thorough test, you want to hook up these 2 leads between every section on every coil. So you can see that there are, I usually call it sort of like 2 primary windings and the secondary. This one's a little bit odd. Normally that 36 ohm and the 230 ohm would just be one coil with a tap on it. That's like an auto former on the primary side to not only it's driven by the 6BG6, but would also have a step-up tap for the high voltage output, and the secondary is what drives the yoke. So right now I disconnected that capacitor, which is what connects to the yoke up on the picture tube. So the horizontal yoke windings are out of the picture. So what else I could check now? I could check just that secondary on its own, and then I can check each of these 2 primary sections on its own. They say you can't really check the filament loop because the Q on it is so low with just being a single loop. Plus, what you really need to check anyways, it's one piece of wire wrapped around the core. Either it's the wire's broken open or it'll be okay. So the challenge for me now is to figure out the wiring on this, because I'm sure now that this is not the stock flyback, so I had to trace out this wiring, which would be a little tedious because some of the wires are the same color. Okay, I think I might have found a problem. Right now I'm checking this 230 ohm winding, which is what produces the high voltage. And I'd mentioned a moment ago, I'm used to seeing this as being one primary with a tap on it, not 2 separate windings. Well, I disconnected all the circuitry from this, so it's just one connection here, and one connection here, nothing else attached to it. Resistance is a bit higher. It's like 360 ohms versus the 230 they specify here, but as I said, that's, well, another reason I'm pretty sure it's not the original. Well, anyways, when I do the ringing test on this, that's the best I can get. Now, I've used this tester on other early flybacks, and it said that they were bad. Like in the RCA 630TS, they turned out to be okay. But it is an indication there could be an issue with this. So for the time being, I'm gonna, I think, put this on the back burner while I see if I can get some feedback from other collectors about what the issue might be. And I think I'm also going to look up the original part number and the various replacements made by Thordarson and others. And I do have a small stash of some new old stock flybacks and some pulls, and I might have something that's compatible. I don't know.